So I wanted to show you what I've been working on for the past few months. It's a Java framework for developing low-code desktop and mobile applications in one code base. So that's pretty nice. It can create Windows, Linux, and Mac executables, as well as Android and iOS executables. It's based on the web technology, so for the UI it uses JavaScript, HTML, and CSS, but you don't have to use those if you don't want to. So you can develop the whole UI in Java completely. So why is it so great? Let's look at it. You can simply import a statics class right here, which provides low-code methods, static methods to create your UI. What do I mean by that? If we look at this, instead of writing new layout, you just enter layout as a method. So this is going to save you writing new and new component, new component, new component all the time, which you might think is not much, but actually it adds up, and having everything lowercase just makes it faster. So in this case, it's pretty simple. It's your static main method, and the first thing you do is to use the app.init method with the desktop UI manager. In this case, by default, the Desku library has support for desktop applications, but not for Android and iOS. You will see later the Desku-Gradle-Starter-App is the repository that has also support for Android and iOS. So yeah, and it also has a build script set up correctly so that everything works fine. So if you want to use it, please use start by using this template. Right, so what's happening right here? We simply set the app name, and then we create a root. So everything is run by a HTTP server, and the JavaScript interactions are handled by a WebSocket server right here. And yeah, that's why we are calling this the web server, which is running on localhost, and the root. So this is the default root right here. And yeah, and then to show a window and create a window, we use the UI manager class and the create method, and then we give over the root that we want to show first. You can also load different roots in the UI, but that's another topic. Right, so what are the features? One code base, as I said, it has minimal memory and CPU usage because we are using the integrated WebView of the system and aren't downloading anything extra like the Java Chromium embedded framework or so. And each US content provided by an HTTP server, as I said. We have also full Java FlexBox bindings, which is pretty nice because this allows you to create complex as well as simple layouts pretty easy. And as I said already, you can decide if you want to code completely in Java or in HTML or CSS to create your components. The main focus is on method chaining and low code, as you saw before, and you will also see in the example I'll show you. And another great thing is that you can update your UI components quite easily asynchronously. Yeah, the default Desku distribution contains support for desktop platforms, as I said, and Android iOS implementations are provided in the starter repository. It uses for the styling the Bootstrap CSS framework, so that makes it easier, and I don't have to create those components myself. But I have to create all the Java bindings for it. So since there are so many, it's quite time consuming to create them in Java. But there are a few basic components already integrated. We'll see that also later. I show you everything that's currently available. You can develop extensions also for this. So here's a list of all the extensions. There's nothing right now because it's a pretty unknown framework. And you can also start with the Desku-Gradle-Starter extension template. There are also some examples in that template that help you get started. Yeah. Yeah, that's quite it. So I'm going to show you how it looks like exactly. Let me just switch to the project. I've got here a test set up. Let's just run that. It's going to take a bit. And here you can see what the code looks like, but I'm going to show you that detail. This is a test class I'm using to develop the components. So you can see images, everything in Java. Here we got some text. You can click on this. Then we have asynchronously updating the components. You can see loading, it's updating. And then we have simple layouts. You can see here it's a vertical layout. Then we have a horizontal child layout and all the text sizes. Then we got the smart and mobile friendly UI layout. So it's a responsive one. If we make the smaller, you see it wraps kinda and changes the order. so it fits better on smaller devices as well as big devices. And then we have the scroll layout. You can see here the events are shown when we scroll. And then we have the page layout, which you can navigate by pressing next or previous. And here you see the elements. I think this is all. And if there's nothing left, you can't go further, obviously. And here is an example for navigation. I went to Google now, but this isn't quite working right now because JavaScript events kinda go. Um, yeah, that's I'll have to fix that later. Then we have overlays. As you can see here in the top left corner is an overlay over the complete page, and we have an overlay over another component right here. The red one is on top, the blue one. And for inputs, we have the buttons. We have different styles. These are the bootstrap buttons. Then we have a text field. You can also see the events in Java right here. Then we have a password field. We have a checkbox, color picker, slider. All the events are also shown. And then we have tables, pretty simple tables. Also support reflection. I'm going to show that too. And then the loading animations. Right, let's dive into the code. So what you're going to do is to create a new class, extend root, and then since this is an abstract class, you'll have to also provide an implementation for load content. This one expects you, this is where your whole Java UI is going to be in. So let's look into that first. Don't worry about this, I'm going to explain that later. So we have the vertical layout in this case that you can create by this function, and then some important CSS stuff is also right in Java. So child gap and padding, for example, are pretty useful ones. But you can add any style by adding just put style, and then the style you want, for example, background color, and then, for example, red. If we change this and rerun it real fast, you're gonna see that the background color is completely in red. So, right. Let's revert that. What do we have here? Right, the image. Images can be quite easily created by providing a class. So, as you can see here on the left, sorry, we are right now right here. This is the home class, and then we have an images folder besides the home class and the pc.png right there. So the path that you're going to provide is relative to the folder this class is in. So yeah, that's pretty nice. So you can directly add your resources next to the class that's going to use it. So you have nice, pretty packaged stuff, everything in one place that is related to that. Yeah, that's pretty nice. And then you can listen to on-click events on any component. In this case, it's the text component that you're listening on the on-click event. And then the event provides the component itself. And as you saw before, it just sets the text to thank you for clicking. Then we have async stuff. In this case, we are just having a simple for loop that waits 1 second, and then we set the text of the component to the int, so the index. Pretty simple. And this just demonstrates that you can call this also on any component. The later function, this creates a new thread and executes code. But you still have access to the UI, right? And you can update the UI in another thread. Yeah. The same, it's not quite the same, but a similar thing is like a utility function that you can call later with an overlay. Let's just run that. I'll show it to you. It wastes 10 seconds right here. The overlay is this one loading, and then after 10 seconds, it updates the component and sets a green background, as you can see here. Right. That's also pretty straightforward. As you can see, everything is based on method chaining and tries to be as low code as possible. And then we have the layouts and text. You can see also right here all the possible sizes out there to make it simple and easy. We have the vertical CL, which stands for child layout, and then the horizontal child layout. Also pretty easy. Then we have the smart layout, as I've shown before, with the responsive stuff. That's that. Then we have the scroll layout right here. You can listen on the on-scroll event for this one. This also is a thing you can do on every component. So you can listen to a on-scroll event for anything. And to make a component, you can also make any component scrollable. So in this case, you can also you set it to true or to false if you want to remove the scroll. And you have to define the width and height of the scroll component, and then of its child's components, minimum sizes. Otherwise, not going to work. Yeah, here we're adding the children to that component. And then we have the page layout right here. We have data, which is just goes from 0 to 9, I guess. Yeah. And then we set a data provider for this one and tell it where to start and how much to fetch per page, how many elements to fetch per page. Yeah, and that's added right here. Then the navigation between components can be done via the router. You can set this quite easily and then navigate between routes. If the user clicks on that, the UI loads that route into it. Yeah, and shows it. Then we have overlays, also pretty easy to create. If you provide null as a parent, it creates it over the complete page. Otherwise, if you provide a parent, right here, it's the last child. So in this case, last added child to layout is the vertical child layout right here. And yeah, this is the example right here with the red and blue one. So we have an overlay over the Then we have inputs. So as you can see, we're listening to the onClick event right here, doing this for 3 buttons, the same thing, and just with 1 integer that's being incremented after each count. That's why it looks a bit weird, because we have 1, 2, 3, 4, 5, 6, 7, and then it continues right here if you click, right? Because it's the same integer that they're using. And setting the text right here with this. Also pretty easy and low-code fashion. Then we have a ton of button variants. These are the bootstrap variants that you can access also via a single method. And then the listeners for the text field, for the password field, for the checkbox label. This is a Boolean value that's returned. Also the values before are returned for all of these. Then we have the caller pick, which is a string. Then we have a slider that's, I think, a double. Yeah, it's a double. And then we have also tables. Tables are pretty nice and pretty easy also to create. You simply call table, then headers, and then you have header 1, header 2, like here in the example, and then you can provide the rows. So this is one row, and this is another row. Data 1, data 2, data 3, data 4, 1, 2, 3, 4, everything nice here. If you want, you can also create a table via reflection. Here's the example. You have a person class with the first name, the name, and the age, and then these are public methods, public fields, sorry. And then you have here the data that we're providing with some mock data. We have John Stamos, the Peter, and the Maria, and their ages and names in this list. And then we create the R table, which stands for reflection table, give it the class that we want. And then in this case, it's person class right here. And then we add the rows. We can go into this, as you can see in your R table right here. And what this does is class and creates the headers for this class right in the constructor. And then you just have to enter the rows. If you want to replace the header with something custom, you can just also do that. Or you can't right now, I'm not sure. No, you can't. You have to provide the class. Okay. Then the result of this is that you have the first name right here. This is the field. Then another field, the name, the age, and John's name is age 34. As you can see, perfect. Works fine. And then lastly, we have some loading animations right here that you can't quite see. Let me restart this. This seems to be a bug from the WebView side, I guess, with scrolling. Right, yeah, now it's working. We have the spinners and another type of spinner. So also the same variants as the buttons right here, and you create them simply via the spinner method, the static one. And the other type is a type row. So this one, yeah, and that's it. What I wanted to show you is how to use HTML and CSS too. No, you can't use HTML. Right now, at least, in a separate file. It's not so easy to do it. But what's easy to do right now is to use CSS and JSON, CSS and JavaScript. As you can see here, besides my home class, I have another file named home also, but with the ending CSS, and another one ending with JavaScript. So what we're doing here is app.getCSS from our home class, so that it knows it's also going to be named home, but the ending is with .css. And it also knows in which packages it is, right? So it has to be in the same package right besides our class. And then we append it to the global CSS, and this is going to be added to every page. So the global CSS is globally really for all the routes. Yeah, and that's why we only have to do this once in our application at the start and append it to it. And that works also pretty easily and fine. So that's all good. And that's pretty much everything that I have at the moment implemented. I can show you the Gradle-Starter-App example if you want. how it looks like, the code. So we have an Android folder, we have desktop folder and iOS folder. So the desktop is pretty much a simple Java project. We go into this right here, and then we have main.java, and what's down here is the same thing in the example, and then we are calling the core method. That's pretty important. I didn't tell that. We have the core folder, which is a folder where you're going to develop your whole UI. As you can see, the only thing we have to do in core is to create the window. Oh, oops, here, right there. Yes, and that's it. We have the Android project. We can go into that too. This is a simple Android project too, and this is where we have the implementations of Android UI and Android UI Manager. So this is the important one. This uses the Android Studio or the Android packages, as you can see right here, and uses also the WebView to use also the WebView right here. Yeah, and then there's stuff implemented for creating the WebView and JavaScript bindings and stuff like that. That's all right here. So if you want to support another platform, for example, you'll have to create those both classes and extend them and create an implementation for that. Right. Then via Java Packager, we can create executables, and with GraalVM, we can create native images for these platforms. On Android, you have to have Android Studio installed to create that, and create a local properties file where we tell them where you have that installed. And then iOS, it's not quite tested yet, but in theory it should work. It uses RoboVM and it's WebView, and you have to have a macOS. So what's pretty nice is that we have a GitHub workflow file right here, which creates a release and generates and uploads all supported platforms, so you can install this and binaries, which you can do by heading over to Actions, select the release, and press and run workflow. And voila, you have everything you need, everything built and finished in one click. It uses Gradle to manage it, and yeah, that's it right now. So thank you for watching. I guess I have everything covered. If you want to contribute, please. It's still in early stages, as you can see, but I've already a working example app and so on, and the only thing missing is really a lot of contributions, so we can have a really good framework from this. Yeah, thanks for watching. See you next time.